Hello everyone, we are Hoa, Mai Anh, Ngọc Trang and Ánh from Group 6 of Tutorial Class 1. Today we are going to present our project, Impacts of some Determinants on Vietnam's GDP. Particularly, we focus on effect of import, export and inflation to GDP. Our presentation includes three main parts: descriptive statistics, result analysis, and limitation and conclusion. Now we go to the first section. First of all, using eView, we obtain the correlation matrix. We can see that they are strongly correlated between export and import, which deliver the message that there could be multi-collinearity error. So we drop an independent variable and we specify we transform dependent variable GDP to GDPG, absolute change in GDP, and drop import out of the model to make it more significant. To explain why, looking at the result of estimated equations, we can see that all dependent variables are significant, that is the p-value smaller than 0.05, and the R-square of the model with export variable equal to 90.95% and adjusted R-square equal to 89.82%, a little bit higher than those numbers in the model of import. Then we obtain the descriptive statistics and the correlation matrix. We can see clearly that there are no highly correlated among regressors, and both exports and inflation variables have positive relationship with GDPG, while export and inflation are in negative relationship with each other. Looking at descriptive statistics table, those number of export variables indicate the great distribution to GDP growth, and we can see all the macroeconomic factor has a positive skewness. Inflation experiences highly right skew data because the skewness is greater than 1. It's because it means equal to 8.066% and it reached a peak of 22.67% in 2008 and had the smallest value equal to minus 0.19% in 2015. To continue, my friend will talk about the result analysis with some tasks of our project.
So now I'm talking about the second part, model analysis and result. About model analysis, we perform several tests. First is testing individual partial coefficient for export and inflation separately. Our hypothesis tests whether each variable has effect on GDP or not. Looking at the eView output, you can see that the T statistic is greater than T critical, so we reject HO, and our conclusion is export has impact on GDP at 5% level of significance. For inflation variation, we perform the same test and find that T critical is greater than T statistic, so we do not reject HO, and we can conclude that inflation do not have impact on GDP. Secondly, we test the overall significance with the hypothesis is whether all the variables have zero effect or at least one variable has effect. We have beta 2 is export and beta 3 is inflation. So we do the F test and we can see that the F statistic is greater than F critical, so we reject HO, and now we can conclude that there is at least one variable has effect on GDP. About testing the rejection on variable, we are adding the net export, which is equal export minus import. So we have the rejection model is the same as the previous part, and the unrestricted model is adding net export variable. So we do the F test, and we can see that the F statistic is smaller than F critical, so we do not reject HO, and we can conclude that the net export do not have impact on GDP, so we still keep the first model. The functional form, we run the linear and logline model to obtain coefficient variation and adjust square to compare them. And based on the UV output, we can see that CV of linear model is greater than CV of logline model. And also the adjusted square of logline model is smaller than adjusted square of linear model. We still prefer and choose logline model to use and test in the next part.
Hello, I'm Chang. I'm gonna talk about the structural change in our model. We use dummy variable and run it in the eView. First of all, we check whether there's any breakpoints in 2011 or not by using choke breakpoint test, and we can easily see from the eView output the p-value is smaller than infer, so we can reject HO and conclude that there's a break at a specific breakpoint year 2011, and therefore the dummy for equal to 1 is for the period after 2011, and the dummy equal to 0 is for the period before 2011. We test in the intercept and the slope. For the intercept, we can see that the absolute T start is greater than the critical value, so we can reject the null hypothesis and conclude, and we have enough evidence to conclude that there's difference in starting GDPG before and after the years of 2011 at 5% of level of significance. And for the slope, first of all, is the expert. We also see the result here. The absolute T start is greater than the critical value, so we can reject HO. And we also have enough evidence to conclude that there's difference in increasing in GDPG before and after the year of 2011, given the same level of increasing in the number of goods and services exported at 5% of level of significance. Similarly, we can see in the inflation, the absolute T start is smaller than the critical value. So in this case, we do not reject HO, and we also don't have enough evidence to conclude that there's difference in the increasing in GDPG before and after the year of 2011, given the same level of increasing inflation rate at 5% of level of significance. And here is the estimated equation for each period. Firstly is the period from 1999 to 2010, and the period from 2011 to 2018. And then we detect 3 errors in our model. Firstly is about the multicollinearity. We can see that the R-square and adjusted R-square are high enough, and all the variables are significant because the p-value is smaller than 0.05. So we can conclude that there's no multicollinearity. And then the VIF of variable is smaller than 10, so we can also go to the same conclusion. In terms of the heteroscedasticity, we use y-test. First, we test with no cross term. We can see that the y start is smaller than the critical chi-square, so we do not reject HO, and we can conclude that at 5% of level of significance, there's enough evidence to conclude that heteroscedasticity is not existed. And we do the same step in the case with cross term. We do the same step in the case with cross term and obtain the W start and the chi-square value. We can see that the Y start is smaller than the chi-square critical value, so we do not reject HO. And from this, we can conclude that at 5% level of significance, there's no heteroscedasticity from the both cases.
We detect by using the Durbin-Watson t-test, and to test whether there is positive autocorrelation or not, we obtain the Durbin-Watson statistic from the EView and compare it with the critical value DL and DU. Because the Durbin-Watson statistic smaller than the DL, so we can reject the null hypothesis, and we conclude that there exists positive autocorrelation in our model because the Durbin-Watson statistic fall into the range from 0 to 2. Test whether there is high order autocorrelation in the model or not. We conduct the BG test and we obtain the BG statistic by using the formula, and we compare it with the chi-square critical value. Because the BG statistic smaller than the critical value, so we do not reject it out, and we conclude that there is no higher order autocorrelation at 5% level significant. In order to fix the first order autocorrelation, we use the autoregressive distributed lag method. And in the EView, we generate a series lag GDBG equal to GDBG minus 1, and we lag for 4 years, and we run the LOS regression. And we check again by using the BG test, and our new BG statistic are smaller than the critical values, so we do not reject the null hypothesis, and we can conclude that there is no higher order autocorrelation at 5% level of significance. And we also check by looking at the p-value. For example, the p-value of resist minus 1 greater than 0.05, so we do not reject the HO, and we do the same for resist minus 2, and so on. And our conclusion is there's no autocorrelation at 5% level of significance. And general conclusions for the project. The first limitation is we can see the effect of import on the GDP of Vietnam because the import variable was dropped out of the model at the first step. Second is our sample size is not really large enough to provide the statistical power of results. And the last is when we see at the descriptive statistic, we have the skewness of inflation greater than 1 and kurtosis of GDBG and export variables smaller than 3. So our sample may be not normal distribution. And we had general conclusion is the GDP of Vietnam was affected by export mostly, and when the export increase, then the GDP will increase positively. And now the second is the inflation's effect on the GDP is not clear enough, and we can see much impact of inflation on this model.
So this is quite consistent with our theory stated in the first part. And we have some recommendations for the project to be better in the future. We can lengthen for a period of time, and we also can consider to include more macro variable on the GDP as well. So it is all for our presentation of the project. Thank you for listening.